All right, number 6 gives us 4 functions and asks which one has an infinite discontinuity. So let's go through each of the 4. This first one is a piecewise function. So f of x is equal to 2 if x is less than 0. So it's going to be going along like that and then get to 0 and stop, and then it's going to jump up to 3 if x is greater than or equal to 0. So the graph of that's going to look like that. That is a jump discontinuity. So not the discontinuity that we're looking for. This one down here, f of x equals x squared minus 49 over x minus 7. Notice that we could factor this top. This is a difference of squares, x squared minus 49. Factors to x minus 7 times x plus 7. And then we've got x minus 7 on the bottom. Notice that these x minus 7s are going to cancel out. They're going to divide to 1, and you're left with just x plus 7. So this is, the graph of this is just going to be a straight line with a hole there. This is a removable discontinuity. All right, up here we have f of x equals 1 over 2x minus 9. So notice that if x here is, what would that be, 9 halves. If x is 9 halves, 2 times 9 halves minus 9 is going to be equal to 0. And so if right here at x equals 9 halves, we're going to have an asymptote. It's going to shoot off toward infinity because as it gets closer and closer to 0, we're going to be dividing by some smaller and smaller amount, so it's going to get bigger and bigger. And so this is going to, on one side, it's going to shoot down to negative infinity. On the other side, it's going to shoot up to positive infinity. And that right there, and you have an asymptote right there at x equals 9 halves. That is your infinite discontinuity, and that's the one we're looking for. This last one, x to the 5th minus x to the 3rd, that's a continuous function. There's no discontinuity there at all.